Welcome back. This is an Aleks homework video on interconverting KP and KC. Not sure about this question. I think it's basically just a rewriting of some algebra. Doesn't seem really hard. I guess it's getting you to understand what you're doing rather than memorizing it, and that's always good. So let's just first of all write down what we know for our case. What is the expression for pressure constants and for concentration constants? Okay, so K sub P is in this case it's based on each balanced equation. So if you see here, you've got 1 mole of nitrogen, 3 moles of hydrogen, and then 2 moles of ammonia. So in this case, the pressure of the ammonia would be squared since it has a coefficient of 2. The pressure of the nitrogen would be to the first power, and the pressure of the hydrogen would be to the third power. So this is not something to memorize. This is something to figure out based on each equation. If you were looking at the concentration constant, it would be the molar or the molarity concentration taken to the second power over the molarity of the nitrogen to the first and the molarity of the hydrogen to the third. So you can see that they're very related. You've got pressure squared, nitrogen to the first, pressure to the third, and then you have the concentration squared, nitrogen concentration to the first, hydrogen concentration to the third. So there is a relationship here. The other thing, anytime that you're trying to convert something with pressure and volume, I would first of all remember that molarity is what the concentration is in. So these brackets are referring to moles over liters. And generically, that would be the number of moles of a gas divided by the volume of a gas. Both of those terms are in the ideal gas equation. So if you look at the ideal gas equation, PV equals nRT, N is the number of moles. Well, if you solve for pressure, since we're looking at Kp here, which is pressure, if you solve for pressure, and remember that moles divided by volume is molarity, then that's probably you'll go farther if you can remember that. So in this case, pressure is going to be the molar concentration times your constant R times your Kelvin temperature. Okay, so we're simply going to rewrite the K sub P expression using the molarity from the other one. Basically, we're going to incorporate both of these together. Okay, so I've got K sub P equals, and you see it's N over V RT. Well, N over V is your concentration of your first stuff. So the stuff on the top is the ammonia, so the concentration of the ammonia times RT squared, divided by the concentration of the nitrogen times RT, and then the cube of the concentration of the hydrogen, RT. Well, you see that you can pull out K sub C. K sub C is NH3 squared, N2 to the first, H3 squared. So you can pull all of Kc out, and all you're left with are some RTs. So you've got a couple on the top and 4 on the bottom. Okay, so I've got RT squared, so RT times RT, because the NH3 is part of the Kc. I've just pulled it out, and then I've got 1 RT from the nitrogen and 3 RTs from the hydrogen. So I have 4 on the bottom. 2 of them cancel top bottom, leaving you RT to the negative 2 power. Okay. So the K sub P is going to be K sub C times RT to the negative 2 power. And you're asked to come up with K sub C. It says, now write an equation below that shows how to calculate K sub C. So all you're going to do is rewrite it with solving for K sub C. So get rid of the RT to the negative 2, and since it has to come to the top now, it's going to be RT squared. So Kc equals Kp RT squared, right? So that's your answer. But I just wonder why that they're doing this problem. I think it's so that you can generically do this problem without even thinking, okay? So look here just a second. if I have K sub P equals K sub C RT negative 2, and then conversely K sub C equals KP RT to the 2 power, really what I'm doing, it can be anyone, all right? The generic formula I wrote in blue here. So it's K sub P equals K sub C RT to the change in moles, okay? Or K sub C is to the negative change in moles. So if you look back up at the top again, you've got 1 mole of nitrogen, 3 moles of hydrogen, so I've got 4 moles on the left, but 2 moles of ammonia. So I've gone from 4 moles to 2. Well, the change in moles is 2 minus 4. Okay, 2 ammonia is minus 4 with the nitrogen and the hydrogen. Well, 2 minus 4 is negative 2. So what is here as the change of N, okay, what is right here is, in our example, negative 2. Well, what if it's a different number? You can jump straight to it and simply go straight to the pressure constant. And if you want the other one, if you want K sub C, and you realize this is 2 minus 4, which is negative 2, then you have to know that it's a negative, and it has to be to the positive 2. So you're looking basically at generics. I think that's why they're having you do this problem. So I hope it helps.